okay. I was just laying around the house, didn't do much. How was yours?
Good, I guess.
Average?
Different.
Okay. Any particular reason why you want to share?
Well, I mean, my grandma's in hospice.
Okay.
Yeah, and they said she'll probably die tomorrow, so,
Sorry.
yeah. So definitely different.
Yeah. My father-in-law went through that
Yeah.
so just about a year ago. About 13 months ago. But when it comes time, you don't want them to suffer, so
That's
the way it goes.
pretty much pumping with a bunch of pain medication right now.
Yeah.
I told you we didn't have a quiz.
I know.
Let's
Yeah,
go.
you were right. Can I go next door? I left my pencil in there.
Sure, you got 3 minutes.
It's good.
Mr. Townsend, do we turn in, like, any papers today?
There's 2 you can turn in at the end of class.
Okay.
One of them you should have done now, and one you won't have done until we do this.
Gotcha.
You guys excited for the ACT tomorrow?
Are we supposed
I ain't
to come
doing
to
it.
school for, not taking it?
Are you supposed to come to school? I mean,
Supposed to, though. Like, they got weird classes in the
So I was just looking at like the map of data classroom,
like the first
and I
period was,
didn't see until yesterday that like I was supposed to put my name, my like math, and my like level,
Don't think I'm gonna go.
like for grade level, like.
for the ACT room?
Mhm.
Oh, I did all that. Don't
Oh,
worry about
okay.
it. Yeah.
So then I'll just
We still haven't
get
finished
sent
our
the
previous-
information.
Really, all I needed, yes, I'm waiting on the university to finalize their plans.
I know.
Like, they have to see like how many students sign up for
That's what
Algebra
it
2 to
is.
know like where they're gonna test.
Okay, I just
So-
wanted to make sure like I didn't.
No, I got it all.
Correctly.
Although if we
I
have
knew
time
it.
for Locust, I really do want to play Locust. We just never have, we're like, let's play Locust, and it's like 2 minutes till the end of class.
Oh, that makes sense.
If I'm not playing Locust,
I like that
who knows?
one.
Yeah, that's what I heard.
What is it?
I like that one.
There's supposed to be a fire drill
Okay.
in this period, yeah.
Dude. I'm not going for the
Wait, wait.
man?
Can you see that?
Hopefully we have time to play Lucas.
Are you gonna drink
We
something?
just breathe outside. That's gross. That's see it.
You know, just there's a few more pieces, it's fine. We can just 3D print some more.
I need to get that.
Yeah, you do.
Let's go.
I get that.
Good. You're supposed to get it.
Like, to the exponent, and then you put it on the outside.
Yeah.
It wasn't in homework.
Yeah, it was. Mr. Townsend, what are we
That's funny.
gonna do on Friday?
Hilarious.
Friday will be test review.
Who are you dressed up for?
Why?
I don't know.
Brian, Ben,
Does he need to
and
wear
I
Have you presented yet?
will be
suits?
out of class that day for
Have you
testing
presented yet?
competition.
Presenting next week.
Or I mean,
Okay,
coding
our script
competition.
isn't done. Uh-oh.
He always wears like.
So-
All right. Well, there'll be the class video, so you can see what questions other people asked.
Okay.
You might try to stop by like Thursday advisory, Thursday near the end of the day to pick up your quizzes. We're gonna look back at, but that's really all you can do.
People wore like everything.
Yeah.
It's a fiction book anyway, so,
I feel like you're dressed more as Tom.
right?
Me?
Gatsby?
Yeah.
Fiction?
Me.
Yeah. I paid attention.
Braden is actually describing himself as.
Guess what? On my reading, I got a 33 on the practice.
Good job.
It was like a test from like 2 years ago, ACT prep. And then on my
Good sign.
English, I got a 31.
He said Gatsby words.
I don't know about
31 for what?
The English.
It's literally talking
Oh.
it's all good.
I don't know
I would
about,
not do that well. in those.
I don't know about math or science because we never took it.
Hey.
Because he's an English teacher.
Is it the ACT?
Yeah. ACT test.
I like that, you're alright.
Dress like an old man, feel like an old man.
You, Mr. Scrocky? I
He's
like
pretty dope, yeah.
He's cool.
All right, are y'all ready to start?
Yes.
Good. Okay. All right. So last time I saw you guys was a while back. Just how we had 3 B days last week, and it was only a 4-day week. This week is almost a reverse, so it is a 5-day week, 3 A days because it's an A week, and 2 B days. However, tomorrow is the ACT for juniors, so it won't be a normal B day. So it's kind of like 3 A days and 1 B day. So you guys get a little bit of a chance to get caught up. But last time I saw you, we started section 3.2, which is where we talked about how to graph logarithmic graphs, which we'll review a little bit today, using some of the logarithmic properties, which we will review today, and give you a close idea of what to expect on the 3.2 quiz. So one of the handouts y'all picked up this morning or this afternoon is front and back. That is 88.
Has a leftover batteries.
Okay, I'll take them. So go ahead and number that as 88, and then the one-sided one is 89.
Wasn't his name like Jake Gatz? Or John Gatz? Jason Gatz?
What are you talking about?
James Guns.
James. Crap, I got that
US
wrong.
history stuff.
Whoa, it's US history?
What was his dad's name again? Yeah, Henry C. Guts.
Are y'all not ready?
Oh, yeah. Yeah, well, we are. The
Diego's.
sophomores are.
I just get my
Diego, you're going to have a permanent new seat. Be quiet. Okay, so let's go ahead and look at 88. The front and the back look similar. So the front is worksheet 1. That is one that I'm going to go over with you, especially since it's been a little while. It's been almost a week since I've seen you guys. And we're going to do this into 3 sections. So I'm going to go over questions 1 through 12 with you, do a quick little reteach, help you highlight the stuff that you guys need to know. Then we're going to flip it over, give you a minute or 2 to try 1 through 12 on the back, make sure that you really understand it, give you a chance to ask questions, make sure that you mark the stuff that you need to study, all that kind of stuff. Then we'll go back to worksheet 1, do the next section, and continue. And then we'll do all of worksheet 3 together. Okay, so starting off questions 1 through 12. Starting off with number 1 just because it's number 1. So this one, you have to know 2 things. One property is when you have an exponent on something you're taking the log of, that exponent can come down out front, which is where the daily meme came from today. If you think of this as an exponent on something you're taking the log of, the exponent can come down out front, right? Okay, and then secondly, you need to know how to evaluate a logarithm without a calculator. Log base 2 of 2 is saying 2 to what power gives you 2. So your answer comes from 7 times 1. Now, within questions 1 through 12, this comes up again in another question. So what is another question that's going to do the exact same thing as this one?
11.
Okay, so let's work 11 the same way. 5 is an exponent on something you're taking the log of. So we're going to bring it down. Sometimes in mathematics you actually bring it up instead of bringing it down, but most of the time you bring it down. And then log base 4 of 4 would be 1 because it's asking you 4 to what power gives you 4. So your answer comes from 5 times 1, or 5. Okay, are there any others 1 through 12 that work out the same way? There is.
Those. 7.
11.
Not 7. Okay, how about 3? X is an exponent on something I'm taking the log of, so we can bring that down out front. And what's the natural log of E?
1.
It is 1. This one's going to come up a lot, so you don't usually want to break it down this much. But remember, natural log just means log base E. So if you want to rewrite that, you can. It's saying e to what power gives you e, and that's why someone said 1. So your answer came from x times 1. Your answers don't have to just be numbers. They can have x's in them depending on how the way the question's written. So knowing that one skill got us questions 1, 3, and 11. All right, for number 2, we got to do something different. And number 2, we need to know this property. And this is the one in your notes I said doesn't really get used until calculus. And it's actually this time of the year that it finally gets used. But if you have a number to the log and the base is the same number of something, all of that just simplifies to be something. So if you've got 3 to the log base 3 of 8, all of that just becomes 8. Some of the easiest questions to do, but you have to recognize that pattern. So look through questions 1 through 12 and tell me another one that fits that pattern. What number? Okay, I agree. E to the log base e of 5, so all that's going to be 5. And I see at least one more. Question 12. 10 to the log base 10 of 7. It's just going to be 7. Obviously, there's not going to be a million of those on your quiz, but enough that they're easy enough that it's worth making sure you know that property. Okay, honestly, if you can evaluate these logarithms like we did in question 1, 3, and 11, the second half of the question, then most of questions 1 through 12, the rest of them, are going to work out pretty much the same. This is 5 times the natural log of e, which we already talked about why that would be 1. So your answer comes from 5 times 1. This is saying e to what power gives you 1, and so that would be what? 0. Anything to the 0 power gives you 1. So what's the answer to 8? 0. 10 to the 0 power gives you 1. Anything to the 0 power gives you 1. Number 9 is like negative 2 times 1. Number 10 is going to be what? What's the base if there's no base written there? 10 to what power gives you 10? 1. And then of all those, to one that I think is a touch harder, when we get to section 3.3, you'll have an option on how to work this one. And I haven't mentioned this to you guys because I haven't seen you in a while, but we did this year decide to split up our big test. So normally we test over 1.9, which was inverse functions, 3.1, which was exponential functions, 3.2, which is the start of logarithms, 3.3, and 3.4. And then that's a 100-point test. This year we're going to do 1.9, 3.1, and 3.2, do 50-point test, and then after that we'll do 3.3 and 3.4 and do the other 50 points. So splitting it up into 2 parts should make it a little bit more manageable to you. So we won't get to that until after our first 50-point test. But in the meantime, you can still work this with exponent rules. Most of the time in mathematics, if you have a negative exponent, you move it to the other side of a fraction and make it positive. But you could go the other direction. A positive 2 exponent in the denominator is similar to a negative 2 exponent in the numerator. And now this is like question number 1. We've got an exponent on something we're taking the log of. That can come down out front. Natural log of e is 1 because it's saying e to what power gives you e. Although you use that so often, you probably just want to memorize it. So your answer comes from 2 times 1. Sorry, negative 2 times 1. Negative 2. Okay, you guys feel okay with questions 1 through 12? Okay, then without a calculator and without flipping back and forth, I would like you to flip over and see how many of these 12 you can get right on the back. Similar properties, similar question types. If you really know what you need to know, then you should be able to get all of those correct. Everybody tried those? Okay, so let me share the answers with you and then we can go over whichever ones y'all need to. Looks like we should have 5, 6A. Remember, your answers don't have to be numbers. 2, 0, 2, -3, 2, -4, 0, 3, and 5. Any of those you disagree with, or you would like me to show you how I came up with that? Yeah.
When it's just log of a number,
Uh-huh. Like this one?
yeah, we just count, we just say it's like log 10 of,
It's understood base 10.
okay.
Yep. So if that bugs you,
Oh,
you're
sure.
welcome to just write in the 10. No base is listed as base 10. We always do work in base 10. In college, one of the most interesting math classes I took was a class called History of Math, and you learn like how like they do math in like Egypt and stuff long time ago. And not all civilizations do base 10 like we do. You know, like if you think of Roman numerals, it's like base 5, I guess. And so we learned to do some math in different bases. And it's kind of interesting because like depending on what base you're in, like certain arithmetic and stuff can be a lot easier than what we do. So there's definitely some arguments for not being in base 10 like we do, but
Do you know what was the easiest? Like,
I mean, it just depends on what you were doing. I don't remember any of the specifics. It's been too long, but okay, flip it back over. Let's look at the next section, 13 through 18. So when we eventually get to section 3.4, that whole section will be about solving equations, and we'll dig deeper into that. But for now, there's really 3 ways that you need to be able to solve an equation. One is from switching forms. If you're given something in logarithmic form, switch it to exponential, or if it's in exponential, you can try to switch it into logarithmic. That is a good strategy. 2, sometimes you can just simplify things, like on number 13. If you know why that is 1, then you are basically done. You gotta still solve the 2-step equation, but and number 14, what does all this come out to be?
8.
So if you know that, then you're left with something you can do in your head. 2 to what power gives you 8?
3.
Good. Not 4, but 3. Don't fall into the multiplication trap. So that would be the second way. And then the third way that you need to know right now is if on each side of the equation it's already been balanced with the logarithms. So what I mean by that is this side's already natural log, this side's already natural log, so that part's already balanced. So you need to make sure that the insides are balanced as well. So you can set those equal to each other, solve. Now, the unfortunate thing about this is you do have to do a little bit more work here because this can be extraneous. Before you circle your answer and move on, you have to plug it into the original problem and make sure that you're not taking the log of 0 and you're not taking the log of a negative number. If I plug this in, the left side would be natural log of 18. The right side would be natural log of 18. So that's good news. I wanted the left and the right to be equal, but more importantly, 18 is a positive number. You can take the log of positive numbers, just not 0, not a negative. If plugging that in had given me 0 or a negative number inside the log, that would be extraneous and we would not include it. Okay, 16 has log base 2 and log base 2, so that's already equal. So we just need to make sure that this is equal. Divide both sides by 3. Try plugging it in. You get log base 2 of 1/2 equals log base 2 of 1/2. No issues with taking the log of positive 1/2. So that is final and complete. In this section, I would say 17 is the one that takes a little bit more thought, so I'm going to skip it for a second. How are we going to solve number 18?
Cancel it.
Okay, and leave us what?
6.
Okay, so the answer to that would be
3.
and then to make sure that's okay and you should include that, plug it into the original question, see that you're taking the log of 6, nothing wrong with taking the log of 6. That is fine. Circle it and move on. Okay, are you guys okay with the 5 or the 6 that we just looked at? Okay, 17 is a little tougher because it is one that we can do in our head. It's one that we don't need a calculator for. However, it is not a nice whole number answer. So, if I thought about 1 as an answer, 8 to the first is only 8, and I need it to be 16. If I think of 2 as an answer, 8 squared is 64, and that's way too much. I need it to be 16. So, before we dive too deep in here, do you guys see why the answer has to be between 1 and 2? Okay, that's also a hint that your answer is a fraction. If it's between 1 and 2, it's some fraction. 1.5, 1 1/3, but we don't want to guess and check all of this stuff. So, first off, you need to remember this. One of my classes did not remember this, but an exponent of a half is the same thing as a square root. Remember hearing that? Okay, an exponent of a third is like a cube root. An exponent of a fourth is like a fourth root. They mean the same thing, just different ways to write it. So you're welcome to do this question in any way that you want, but what seems to be the easiest for most students is to do this in 2 steps. I'm going to take 8, raise it to some power, get it to be a smaller number, and then see what I can raise that to get to 16. If I do it in 2 steps, it's a lot easier than trying to just do it all at once. Now, I really don't want to take the square root of 8, because the square root of 8 is not a nice whole number. But the cube root of 8 would be what? 2. So let's say I take the cube root of 8 to make it 2. Then 2 to what power gives me 16?
4.
So what I really want to do is I want to raise it to a third and raise it to the fourth, but I need to do all that at once. So multiply those two. 4/3 is the answer to that.
That's crazy. Yep.
And you're in one step, yeah, it's pretty tough. But if you think of a fraction, because we knew our answer had to be a fraction, that would lower the space, and then once you get to here, it's a lot easier to see. So I didn't want to square root it because the square root of 8 is not a nice whole number. I didn't want to fourth root it because the fourth root of 8 is not a nice whole number. But the cube root of 8 came out to be 2, and that worked out great. Okay, so circle the questions you think you might need to look back at, and then take a moment, flip your page over, and try the same 6 type of questions, 13 through 18. Same thing, I will share the answers once you've had time to do them, and we can go over the ones you need to go over.
fire drill thing is true.
The fire thing drill what?
If the fire drill thing is true. That there's one of this during this class.
It's at the very end of class.
Oh.
Unless something's come up that I haven't heard of. Okay, anybody like more time for these 6? Okay, tell me what you got for number 13.
1/2.
Okay, I agree. Number 14 should be,
4.
I agree. Number 15,
Extraneous.
Yeah, extreme.
extraneous is not an answer.
No solution.
It's not-
No solution. The only thing that you thought might have worked when you plug it in makes you take the log of a negative number, so it can't be kept. No solutions. Number 16 is 1/15. Number 17 is 3/2.
Yep.
And number 18 is 4.
Yes.
Okay, any of those you'd like me to explain and go over? You guys are okay with 17? How I came up with that? Okay. All right, now of course, any of those questions that you missed, now is certainly the time to mark them up in a way so that you remember to review them. If you missed them right after we talked about similar questions on the other side, then expecting yourself to remember them on Wednesday is too much. Okay, last little section of this, and then we can do the other side and move on to worksheet 3. But number 19 wants us to state what the inverse of this is. So we did this in the first part of the 3.2 notes, and you really just need to memorize this. This is not an algebraic process. You need to memorize that 2 to the x is the inverse of log base 2 to the x. The reason why we ask you that and want you to know it is because if you can graph 2 to the x, Christian, you want to join us?
Yes.
Okay. If you can graph 2 to the x, and you know his inverse is log base 2 to the x, this is why we did those 2 days of inverse functions recently, is so that this is just a little bit easier for you. 0, 1 becomes 1, 0. 1, 2 becomes 2, 1. 2, 4 becomes 4, 2. Just switch x and y, and then you have his inverse. Also, it's not important right now, but notice there's that line of symmetry at y equals x that a function and his inverse have. And if you can do that, then what's the plus 4 going to do?
Shift to the left.
Okay, and I've got a couple points that I'm sure about, so I can move all these points left 4 and reconnect them. And then this, if you're going to have more than one graph on your thing, you need to make sure you label which one's the answer. If you have 2 graphs there and one's correct and one's not, I can't just give you points unless you tell me which one it is. This is called f of x, so labeling this guy f of x is plenty. Or you can just erase the other ones. And then of course, once you have that graph down, then a lot of this becomes much easier. I can describe the x values. He approaches -4 on the left and infinity on the right. He goes down forever and up forever. Granted, it is up slow, but he does keep going up if you keep going to the right. The asymptote is the line that he approaches but can't cross. And this time, it's a vertical line. Unlike when we did exponential functions, it was a horizontal line. This is a vertical line where x is always -4. It looks like the x-intercept should be -3. I'm pretty sure about that point because I was keeping up specifically with a couple points. The y-intercept I'm pretty sure is 0, 2. Looks right. And then when x is 4, it looks like y is 3. But let me give you one more piece of advice here. Especially these last couple. These are very easy for you to check. And it helps you confirm that your graph's correct. If I'd accidentally went right 4 instead of left 4 or something, all you have to do is plug 4 into the equation and solve for y. Well, what is log base 2 of 8? 3, because 2 to the third is 8. What is log base 2 of 4? So when x is 0, y is 2. It takes you just 2 seconds, and then you're 100% sure about these, and the fact that these points look like they're on the graph makes me feel good about my graph too. Would maybe help me catch some of my mistakes there. Okay, so if you got some questions about 19 or 20, go ahead and ask. Otherwise, flip it over and see if you can apply the same things on your 19 and 20 on the back. Let's give everybody one more minute to get caught up. Okay. So question 19 doesn't necessarily have anything to do with question 20, but you should be able to tell me without doing any work here. The inverse of 3 to the x is log base 3 to the x. However, question 20 is still base 2. So graphing 2 to the x is a good idea. Specifically because 2 to the x has a couple easy points to find. Switch those x and y, and then you get his inverse, which is log base 2 to the x. Again, if you have more than one graph, make sure you're naming them. And for this question, it has a transformation of left 8. So all of your points should have been shifted left 8. Reconnected. Something like that. Okay, and now it looks like the domain approaches -8 on the left, infinity on the right. Goes down forever and up forever. The asymptote is this vertical line, x equals -8. The x-intercept, I'm pretty sure that's at -7, 0. I'm pretty sure about that point because it seems to be one I was keeping up with. The y-intercept, I think is 3. But how can I know for sure? Right. Solve it algebraically. It doesn't take more than 2 seconds to plug in 0 for x and solve for y. Log base 2 of 8 would be 3 because 2 to the third gives you 8. And that makes me feel good about my graph. There really was supposed to be a point there where I'm predicting it to be. And then when x is -4, I think it's 2. But since it only takes a second, I'm going to go ahead and plug in -4 and solve for y. Looks like 2 works out. Okay, so here in a few minutes, I am going to suggest a couple handouts you guys look at over, but worksheet 1, worksheet 2 would probably be the one I would make sure I was fully comfortable with first. Your quiz will not look like worksheet 1 or worksheet 2, but it is the one that would be most similar to your quiz. A little bit of graphing, a little bit of properties, a little bit of equation solving. So anything about worksheet 1 or worksheet 2 that y'all would like to get clarification on? Okay, then the last thing I got for you today is worksheet 3, and I'd actually like to do this one in opposite order. I think it makes sense to do question 3 before question 2 to question 1. Question 1's kind of hard if you're just in the dark here, but to be able to graph the questions in question 2 without a calculator, we need to remember our transformation rules. So like this one, what happens when we add 2 directly next to x? Okay, left 2. If you're adding 2 to the parent function instead, what is that going to do? If you multiply your parent function by a negative, that reflects the x-axis. Yeah,
I'm sorry, was this 89?
yes.
Okay.
Now, I don't count off for this, but try not to say it flips over the x-axis. I know the action looks like a flip, but when a flip is not a real transformation. Reflection is a transformation. If you can do that, that's what this one is. You're multiplying the parent function by negative, reflect x-axis, but the one I'm most concerned about is this one. If you multiply only the x by a negative, that is how you reflect over the y-axis. You guys often get this one and this one mixed up. Are we okay with those transformation rules? Okay, then in question 2, all of these, we're going to need to know what log base 3 of x looks like. So let's go ahead and graph that well one time, and then we'll distill it for all 4 graphs. So if you can graph 3 to the x, like we did on the other worksheet, switch x and y and all the points you know, and you end up with log base 3 of x. We'll come back and do the transformations in a minute. But got a couple points that I'm pretty sure about. All 4 of these. Use this as a parent function. So might as well just copy it 4 times. It's the same thing 4 times. Now, of course, it's not going to hit the exact same points. But remember, log base 2 of x, log base 3 of x, log base 5 of x, log base e of x, they all basically look the same. At a quick glance, they all look the same. Okay, so now that we've got down what log base 3 of x looks like, what does this transformation do in part A?
Goes to the left of 3.
Okay, so scoot your points over 3, reconnect them, make sure that it looks like your whole graph shifted left 3. Vertical asymptote should be 3 to the left. The whole thing should be 3 to the left.
Wait, wouldn't the y-intercept be 1?
The y-intercept?
Yeah.
Yes. I didn't plot this point very well. This point should be here. Like that. Okay, and B, what does this negative out here do?
Reflects across the x-axis.
X-axis. So any point on the x-axis is going to land on the x-axis. Other points are going to flip over. Reconnect them. And it should visually look like it has flipped over the x-axis, or something's wrong. Again, make sure you label which one's your answer if you've got more than one thing on your graph. Let's skip to D, because I think C is the hardest one. Now, we just had plus 3 over here is left 3, but notice I knew that 3 was being directly added to the x because of the parentheses. If it's added outside of the parent function, that instead is going to be up 3. Oops. So same idea, move all of your points up 3, reconnect them. The graph should look like it's 3 higher. And then that's pretty good for a 10-second graph. Okay, has everybody got A, B, and D? Okay, the one I'm concerned about is C. So first off, let's rewrite this a little bit. this is optional, but instead of saying 3 minus x, we could say negative x plus 3, just switching these two around. I'm not changing anything. But because of this negative, what does this negative do?
Flips it across the y-axis.
Good. Y-axis. So let's do that. This point flips over. Flip all three of the points that I was sure about. Now here's the thing, this came up in our notes and I tried to emphasize it for you, but it was a lot of information last time. This plus 3 normally means left 3, but if you're also reflecting over the x-axis, it doesn't look like it, but this negative is actually going to both of these. So this is actually right 3. The rules for left and right transformations are opposite when you do a y-axis reflection. So we actually need to go right 3 for our final answer. Okay, and I got too much going on here, so I'm erasing my other stuff. Regular logarithmic graph reflected over the y-axis, and then you might think it goes left 3 because of the plus 3, but because it was reflected over the y-axis, it actually has the opposite rule, so it actually goes right 3. Now we won't allow calculators on this quiz, but if you want to graph this one, if you have your own calculator today, I had to turn in calculators for the ACT today, so I don't have any, but if you want to graph it, you can see that it does work that way if you have any doubt. Now, I feel like the build up to that one really helps quite a bit in question 1. Question 1 doesn't say you have to graph it or anything, doesn't need to be an accurate graph, but I certainly think it helps if we have a visual. So what is the natural log of x graph going to look like?
Similar to
2 to the x?
Not exactly.
2 to the x looks like this. Natural log of x does not look like that.
Oh,
It's going to look like all the other logarithmic graphs. Whether it's log base 2 of x, log base 3 of x, log base e of x, this one, log base 10 of x, they're all basically going to look like this as a quick sketch. Because of this negative, we're going to reflect it over the y-axis. So that's going to basically look like this. And then the one they want us to think about is 1 minus x. So this is a positive 1, which would normally shift it left 1, but because we're reflecting over the y-axis, it actually shifts it right 1. So, equation of the asymptote, it was at x equals 0, flip it over the y-axis, it's still at x equals 0, and then shift it right 1, and now it is at x equals 1. The domain was 0 to infinity, flip it over the y-axis, it became negative infinity to 0, shift it right 1, now it's negative infinity to 1. The main thing is, though, you need to know to go to the right 1 and not the left 1. And again, that just doesn't come up in algebra too much, so I understand why that's one's not as familiar, but you still need to know it. Okay, so finally, again, of all of the handouts from section 3.2, the ones that I think are most important would be 88. That was the worksheet 1 and 2 that we just did today. That would be the one I would scan over and make sure I felt the most comfortable with first. Again, your quiz does not look exactly like that, but your quiz is most similar to that one. Not a bad idea to look at 86, where we started graphing logarithmic graphs, especially if that part is hard to you. Not a bad idea to look back at 87, where we did some logarithmic properties and some examples of each one. And not a bad idea to look back at 89, which was worksheet 3. But that quiz will be at the start of next class. Also, I'll be taking up 2 of these handouts for grades. you should have them all done because we've done them all together in class. But 87 and 88 are the two I'm going to give some participation points for. As always, if you want to go ahead and just turn those in, you're welcome to. They are opened up in Google Classroom already. And if you want to wait and hand them in Wednesday at the start of class, then that is fine too. But you need to be prepared to do one or the other. All right, and with our fire drill today, you guys have about 20 minutes. So if you find something that I can help with, then please let me know. 2:15, 20 minutes from now. Otherwise, that's all I've got for you.